Now you know that we're starting to have fun, right? We've got not just cosine, but cosine squared. Now remember, you can't add cosine squared and cosine because that's like trying to add x squared and x. It just doesn't work. Now, speaking of x squared and x, you may recognize that this is an equation that is quadratic in nature. Quadratic in nature just means that we can rewrite some things so that it looks exactly like a quadratic equation. It has quadratic properties in terms of how you solve it, but we can just ignore some of the messy things for right now. For example, the cosine. It's kind of messy. But if you make this declaration, if we let u equal the cosine of theta, then all of a sudden my equation turns into 3u squared minus 5u plus 2 equals 0. And we don't have cosine running around everywhere. We just have u. And that's a much easier problem to look at. And when I see something like this, I go through my progression for solving a quadratic equation. Number 1, can I use the square root property? Well, no, because I have u squared and I have u. 2, does it factor? Yes, this guy factors. He's going to factor as 3u minus 2 times u minus 1. Now, it's very easy for me to make mistakes whenever I factor. So if I make mistakes and I check my work, you should probably check your work too. So 3u times u is 3u squared. Negative 2 times negative 1 is positive 2. On the inside is negative 2u. On the outside is negative 3u. And that gives me a negative 5u altogether. Great. Solving this, u equals 2/3. Or from the other factor, u equals 1. Now, I changed colors when I went to this u substitution. That's a signal to me that I haven't actually finished the problem. Even though I have u by itself, that's great, but the original problem was written in black. I need to go back to black and rewrite the u as cosine of theta. So now we have this. Cosine of theta is equal to 2/3, or cosine of theta is equal to 1. Now again, since we're sticking with having theta between 0 and 2 pi, we're not going to be writing all solutions, just those between 0 and 2 pi. So when does cosine equal 1? Cosine equals 1 when theta is equal to 0. That's when you are facing, due east, and yeah, that's the only place where cosine equals 1. Now I know you come back around, it's going to be hitting 1 again at 2 pi, but again, the restriction is less than 2 pi, not equal to 2 pi, because 0 and 2 pi are coterminal. Now for this other part, cosine equal to 2/3, that's not a nice guy. That's okay, because I'm going to go to Mr. Calculator here and figure it out. Now, remember, all students take calculus. Cosine is going to be positive in 2 different places. It's positive in quadrant 1, and it's positive in quadrant 4. When I use inverse cosine, it's only going to give me the solution that is over here. But I also need to get the one that's going to be down here. So I'm going to have to play around with the numbers a little bit to get that other guy. So let's see what the calculator says. If I do second inverse of cosine 2/3. Okay. Again, I'm in the right mode. It says radians. This gives me that theta is approximately 0.8411. All right. That's one solution, but there is also another one. So that's one solution, and my other solution is going to be this guy that's down here in quadrant 4. Now, keep in mind that this is that first value, the 0.8411. This guy down here would be negative that. So what I can do is I can do 2 pi minus that answer, and that's going to give me the other solution. So 5.4421. 3 solutions. One that we were able to find without using a calculator, and these other 2 that required the use of a calculator. Now, I didn't need a graphing calculator. I could have just used a regular scientific calculator. But yeah, and I think it's very helpful to look at the picture here so you know, okay, this is the one that inverse cosine gives me. The other one's going to be the same measure but going backwards, a negative. And you see that over here where it says like minus this answer right here. So it's the 2 pi, but going backwards a little bit. And so we end up with something that is between the 0 and 2 pi. All right, let's take a look at the next one. So the next one says 1 plus sine of theta equals 2 cosine squared of theta. Well, this does not look like fun, but there is something that we can use. And it's going to come down to this guy right here. I don't want to write cosine squared. I've got sine. I have just plain sine, so it'd be nice if I had sine squared so that I could maybe do some factoring or see it as something that was quadratic in nature. But we do have a Pythagorean Pythagorean identity that will allow us to rewrite cosine squared. We get to rewrite this as 1 minus sine squared of theta. So again, remember, sine squared plus cosine squared equals 1. And then we just manipulate this so that we can rewrite cosine squared. So we solve cosine squared in our heads, and then we get that. All right. All right, so now we need to distribute on the right. So we have 1 plus sine theta equals 2 minus 2 sine squared theta. Now the rest of this is about moving your terms so that you get everybody to the same side, because we're hoping that this is since it's quadratic in nature, that maybe it'll factor, right? So I'm going to move all of these guys to the left side, and that's going to give me a positive 2 sine squared theta plus sine of theta. And then get the 1, move the 2 over, so 1 minus 2 is minus 1, and this equals 0. Now, you can do a use substitution like we did in the last problem, but the more of these you do, the more you might be able to see, oh, you know what? I'm going to see the sine squared like it's x squared. I'm going to factor this using 2 sine of theta and sine of theta. Again, you don't necessarily have to do it that way, but it just depends on your comfort level, right? We've got to factor the 1, so it's going to be a plus 1 here and a minus 1 here. And you can see how you will get a minus sine of theta and a plus 2 sine of theta, so altogether is a plus 1 sine theta. All right, so solving this, just like I'd solve for x, I'm going to solve for sine of theta. Sine of theta is equal to a positive 1/2. And again, maybe I shouldn't have done that. Maybe I should take the time and remind you of what's going on here. You would say that 2 sine of theta minus 1 equals 0, or sine of theta plus 1 is equal to 0, right? Get sine of theta by itself. So here in the first one, you would add 1, divide by 2, and in the second equation, you just subtract 1. All right, so here, on the unit circle, when does sine equal 1/2? Well, since sine is positive, and sine is y, that's going to be in those top 2 quadrants, so quadrants 1 and 2. And when sine is 1/2 is when our theta is equal to pi over 6 or 5 pi over 6. And then when does sine equal -1? Sine is the y value, and so it means it's going to be underneath the x-axis and actually going to be pointing straight down, because -1 is the minimum value for sine. That means that theta is going to be 3 pi over 2. So we get 3 solutions. But you know what? Let's check with the graphing calculator to make sure that it all matches up, right? So let's graph the left side of the equation, which we have as 1 plus sine of theta. theta or x in the graphing calculators, it's not going to matter. On the other side, we have 2 cosine squared. So 2, let's do parentheses here, cosine of x, close, and square that. For our window, let's go from 0 to 2 pi, because that's what we're restricting ourselves on. And we'll go from 0 to 3. That should get everything for us. So let's see the graph here. Sine's going to dip down to 0. That's going to curve back up to 1. And here is cosine squared. Okay, so we can see from the graph here that we have 1, 2, 3 points of intersection. This one over here is corresponding to whenever theta is 3 pi over 2. And these first two, this is going to be pi over 6 and 5 pi over 6. If you don't believe me, let's go to trace. And we can type in second pi, or pi divided by 6. And it gives me 1.5. And you see it's right there at the intersection of the red and the blue. If we type in 5 pi divided by 6. There you go. And then finally we have 3 pi divided by 2. And there we go. Got everything that we wanted, checked out everything, and now we're good. Now, we got lucky here on these problems because both of them, though they were quadratic in nature, they both factored. But what if they don't factor? What do we do then? Guess you should stick around.